different methods. We're looking at square root method, factoring, box method. When that didn't work, then we talked about completing the square and quadratic formula. The last piece is solving an inequality, which is actually very, very similar to actually solving the equation. So we'll start out just setting it equal to 0 and solving that. Then, essentially, if you were to look at the graph of a quadratic, okay, what we've been solving when it equals 0, you're finding where it hits the x-axis. So in this case, you would find your a and b. Those would have been your solutions. But I could ask you, when is this thing greater than 0 or less than 0, in which case you would be giving me an interval. If it were asking where it was greater than 0, then it's from negative infinity to a and from b to infinity. If I ask you where it's less than 0, less than is just below the axis, so it's in between the a and b. So like on this one, when it's upside down, this one is greater than 0 in between a and b. It's less than 0 on the ends. So for any of these quadratics, I could ask you, where does it equal 0, where is it greater than, where is it less than. In this case, if I said, where is this one greater than 0? Everywhere but the vertex. So it'd be negative infinity to a and from a to infinity. If I asked where this one was less than 0, is it ever less than 0? So it'd be no solution. If I had one like this, where is that one greater than 0?
Everywhere.
Everywhere. Negative infinity, positive infinity. Where is it less than 0? Nope. So you might have some where it's always positive, always negative, or we might have a no solution. All right, if I ask you to solve this inequality, so I want to know where this one is less than 0. First, we are going to pretend it wasn't equal to 0. So if I were asking where that was equal to 0, we would try box method. Because it's a 1x squared, we could do the shortcut. So x squared breaks into x. What two numbers multiply to negative 12 and add to negative 1? Okay. So let's find out where this equals 0. If I want to know where it equals 0, you would set each of those equal to 0. So that's when x is 4 and negative 3. What I recommend from here is using a graph to help you. Where it equals 0, those are just the points where you hit the x-axis. So we hit the x-axis at positive 4 and negative 3. My graph doesn't have to be real accurate. We could grab a graphing calculator and get the graph, but is this one going to open up or down? It's a positive x squared, so it just opens up. If it were a negative x squared, then it would be upside down. So we just need to look at this graph, and that's really all I need right there, the 2 points where it equals 0, and then the shape of that graph. I want where it is less than 0. Is that above or below the axis? Below. So if I want the less than, I want the below, we're going to give an interval. It's not an equal to, so we do parentheses. It starts at negative 3 and ends at 4. That means if you plug in any number between negative 3 and 4, you're going to get a negative answer. If I put in a 0, I get negative 12, which is less than 0. So that is my final answer. On those inequalities, we are looking for an interval for the answer. Questions on that one?
Will we ever have the answers that The U thing?
Yes, if I had asked for greater than 0 on that one, it would have been the two ends, so you would have had a union. Alright, so let's look at B. So what do I do first? Box method. X squared breaks into X. What numbers multiply to negative 15 and add to negative 2? Okay, so what things would make that equal 0? If I want to know when x minus 5 equals 0, that's when x is 5. So if we think about our graph, we hit the x-axis at negative 3 and positive 5. Does this open up or down?
Up.
Up because it's a positive x squared. Okay. Again, I asked you for less than. So is that above or below? Below. So those less thans, we're getting part below the axis. Because it had an equal to, that means brackets. So this starts at negative 3, which would have a bracket, and ends at positive 5. Questions there? Let's just keep doing this. All right. So what do I need to do here? Box method. So the 2x squared goes here, and the negative 12 goes here. So first we multiply, which gives us a negative 24. And they need to add to positive 5. So what numbers would that be? Negative 3x and positive 8x. So factor, we get x and 4, 2x minus 3. Okay, so then we set each of these to 0. So that's negative 4. And a positive 3/2. So when we just think about the graph, you don't have to be real precise with this. You know, if you just want to say this is negative 4 and this is positive 3/2, I'm not grading your graph. We know it was a positive x squared, so it opens up. This time I was asking where this was greater than 0. So greater, is that above or below the axis? Above. So that would be here and here. So we go from left to right, so this one is coming from negative infinity and stops when it gets to, it wasn't equal to, so we go ahead and put a bracket on the -4. Union, this one starts at 3/2
Oh, yeah.
and goes to infinity. Infinity is always get a parenthesis. Why don't you guys try the next one?
3/2 gets a bracket too, right?
Yes, because of the equal to. Just a couple things to keep in mind. When you set this up, you always need 0 on one side before you do the box method. So if I had like greater than 4 or something like that, first you would need to bring that 4 over. Second of all, for it to be for box method to work, your square term has to be positive. So if this were like a -3x squared, what would your first step be? Multiply by -1. And when you do that, what happens to the inequality?
Flips.
It flips. Good. All right, so I need two things that multiply to a -12 and add to -11. So -12 and +1. This is 3x and 1, x minus 4. Okay, so if you set each of those equal to 0, you get -1/3 and +4. So if we think about our graph, here's 4, -1/3. You can be more precise, but we don't necessarily have to be. This was greater than, the first term is positive, so it will open up. We're asking where it is greater than 0, so that is
-1/3,
come in. Greater than is above the axis, so it's 2 pieces. How do you, Elmer?
Oh, so how you? It's very good. I sent it to your Chromebook, bro. Take my freaking Chromebook. I'll steal it again.
This doesn't have an equal to, so parentheses are brackets.
Thank you, Mr. Garcia.
Have a good day.
Yeah, me too.
Thank you. So -infinity to -1/3,
Uh-oh.
union 4 to infinity. So you have to watch that parenthesis or bracket. All right, questions there? We're just going to keep practicing these. This is the only piece today, so we'll do a couple more, and then I'll give you guys some time to work. All right, so what would be my first step here? Yeah. We need to do box method, but we want that to be positive, so we take everything times -1. So that makes it a less than 0 now. So then we try the box method. So I multiply, those multiply to 15 and add to -1. Is there anything?
No.
Okay. Why don't you graph this real quick for me? So grab your calculator. Let's take a look at that graph. So when I plug this in, it looks like this, doesn't it? Yeah. Does this thing ever equal 0?
No.
No. Where is this thing less than 0? Never. So no solution.
Is there a way to tell like right off the bat?
No, not really. So you just kind of have to work them out.
So it's just when you can't do it by hand.
Yeah, basically if box method doesn't work, then go ahead and check and see what happens. If it would still give a solution and box method didn't work, then you could always do quadratic formula to solve it. But I'm going to try in general to give you a little bit nicer problems than that on this. Okay, let's do, I want to actually, can I skip this one? I'm going to do this one instead. Sorry, I'm going to change it. Let's do this one. Okay. So first step, box. Do we have to draw the full box?
No.
Okay. So that gives me an x. What two numbers multiply to positive 1 and add to negative 2?
-1.
So what makes this thing equal 0?
1.
1. If you set x minus 1 equals 0, you get a 1. If you're not sure what that's going to look like on your graph, you could always plug it in. If you graph this thing, x squared minus 2x plus 1, we see that's the only place it hits the axis. So if I want when this thing is greater than 0, not greater than or equal to, just greater than, what would I have to do? Negative infinity to, would be all of this and all of this, but the one thing we can't have is the 1. So you would have to do negative infinity to 1, union 1 to infinity. Because at 1, it equals 0. And I asked when it was greater than 0. Last question. How many solutions are there to the equation f of x equals 3? So if I'm looking at this graph right here, using that, f of x is the same as what variable?
Y.
So I'm saying how many times on this graph does y equal 3? So let's see, that's when y equals 0. Y equals 3 would be up here. How many times would that hit the graph? 2. So how many solutions would there be? 2. How many solutions would there be to f of x equals 0?
0.
How many times does it equal 0? Once. What if I said f of x equals negative 2?
0.
0. It's never equal to negative 2. All right. Questions? That's my stopping point.